We have learned a lot this semester, so let's review some. Be sure to read the disclaimer, however. These are just a few extra problems that you should use to review for your exam. Don't forget to go over all of your old tests. You can look over the old test reviews, your labs. Those are all good places to look for review. You also have a WebAssign review for the final that you can make use of. I'm going to go through some of these integrals in number one. So let's start at the beginning. And it is just 4 over x squared plus 9. If you really wanted to, you could use u substitution on this. You could make this look exactly like x squared or u squared plus 1, which is an inverse tangent problem. But if you have the formula for the integral of x squared plus a squared memorized, then you know that the answer is 4 over 3 times the inverse tangent of x over 3 plus a constant, because 9, of course, is 3 squared. But if you needed to rewrite it and do it with u sub, you certainly could. And you'd get the same thing. B looks almost exactly like A, except B is definitely a u substitution problem because we have the x sitting on top. That way, when we let u be equal to x squared plus 9, the magic will happen. Du is 2x dx. So we still have 4x sitting on top. We have u down below. I'll replace dx with du over 2x. So 4 and 2 leaves me with a 2 sitting out front. Du on top of u. So 2 times the natural log. Absolute value of u. Don't really need the absolute values because u is equal to x squared plus 9, which is always positive. C looks almost exactly like A and B, except it has a squared sitting on top, which means we have to treat it completely differently. Yes, still just x squared plus 9. Because now I have the same degree on top as I have on the bottom, and if the degree on the numerator is at least as big as the degree of the denominator, that means we need to do some long division. X squared plus 9 goes into 4x squared 4 times. That goes away, that becomes a minus. So this is equal to integral of 4 minus the integral of 36 over x squared plus 9. We did the integral of 4 over x squared plus 9. 36 over x squared plus 9 is almost exactly the same. So this is 4x minus 36 over 3 times the natural log of x squared plus 9 plus a constant. Okay. Now you can approach this two ways. Hopefully you look at it and you immediately think trigonometric substitution. You can divide it into two pieces or you can do it all at once. I would probably divide it into two pieces because we can look at, I'll left my dx off, integral of x over the square root of 9x squared plus 4. That is something you can use substitute, because if you let u be the thing underneath the radical, magic. Then we have, and let's do it this way, put a minus in front. Then this piece we'll use the trig sub on. So I'm going to do this piece first. I'll label it part 1. So U is the thing underneath the radical, and actually you don't need to watch me U substitute. You have U substituted time and time again, so I'll meet you back here when I get it. Finished up the U sub. I ended up with 1/9 of the square root of 9x squared plus 4x plus a constant. Turn the page over and I wrote down just the part that needs the trigonometric substituting. So 9x, actually 3x because it's the square root of 9, needs to be equal to 2, and we have a plus sign here, times the tangent of theta. If we didn't have the 9 sitting there, it would just be x equals 2 tangent theta. So x is equal to 2/3 times the tangent of theta. So dx is equal to 2/3 times secant squared of theta d theta. I always go ahead and write it down because it helps me to not forget. Most common mistake in trigonometric substitution is forgetting to plug in your dx. So instead of dx, I have 2/3 secant squared of theta d theta divided by the square root of 9 times 2/3 tangent of theta, whole darn thing squared, plus 4. Since it's been a while, we'll go through the algebra here. We still have 2/3 secant squared theta d theta sitting up above. Down below, I have 9 times 4/9 times tangent squared of theta plus 4. Instead of writing things over and over again, cancel those 9's. So I have the square root of 4 tangent squared theta plus 4. I'm only going through all of these steps once. Tangent squared plus 1 is secant squared. So this is 2 secant of theta. Whole bunch of algebra going on. So let's see, I still have 2/3 secant squared of theta d theta sitting on top. And down below, I have 2 times the secant of theta. So I'm going to come way down here. Let's see, I have 2/3 divided by 2. I'll put my 1/3 outside the integral. I have secant squared on top. I have secant on the bottom, so I cancel 1 away. Integral of secant of theta. So that's 1/3 natural log absolute value of secant of theta plus the tangent of theta plus a constant. So now I have to draw my triangle because I need to bring my x's back. Here's theta. 3x over 2 is equal to the tangent of theta, because 3x is equal to 2 times tan theta. So tangent is opposite over adjacent. The other side will always be equal to the expression you started out with, opposite squared plus adjacent squared. So this is 1/3 natural log absolute value of secant, which is hypotenuse, over adjacent, plus tangent, which is 3x over 2, plus a constant. So going back to my original problem, which was the integral of x minus 3 divided by square root 9x squared plus 4, it's equal to my first piece plus my second piece. And as always, I'll write 2 big plus C. Now, if you want to challenge yourself, try doing it without dividing it into 2 pieces. I'll write that down and you can compare later. So are you sitting there saying, but Ms. Sleeper, you forgot the minus 3. Yeah, I did. The original problem asked for minus 3. I wrote it there. I ignored it when I wrote it on the other side. So I did need to bring it back right here. And then I redid it all as one unit. You end up integrating secant, which gives you the exact same thing that we ended up when we did it doing U substitution. Pretty cool. Okay. Let's look at part E. Looks like a straightforward partial fraction decomposition problem. I'm going to go ahead and factor it as I write it down. 2 numbers whose product is -6, whose sum is -1. Minus 3 plus 2 works for me. So I have a over x minus 3 plus b over x plus 2 is equal to x plus 7 over the product. And that should be minus 3 plus 2. So a times x plus 2 plus b times x minus 3 is equal to x plus 7. Make good choices. If x is equal to -2, then b times -5 is equal to 5. If x is equal to +3, then a times 5 is equal to 10. So a is equal to 2. I'm going to write things on the other side of the paper, meet you back here. I wrote it down and just went ahead and finished it up because that one's easy. Next one's a little more challenging because we have more stuff in the denominator. We have the integral to x cubed minus 4x minus 8. So first thing I do is I check and I see that the degree of the denominator is 4, the degree of the numerator is 3, so I can't do any long division. So I'm going to go ahead and rewrite this as x times x minus 1 times x squared plus 4, which decomposes into, and don't write the integral down yet. It decomposes to x cubed minus 4x minus 8 over all that stuff. A over x, b over x minus 1, and cx plus d over x squared plus 4. So now I multiply by the denominator. I'm left with the numerator on the left-hand side. The x cancels, so I'm left with a times x minus 1 times x squared plus 4. The x minus 1 cancels, so I'm left with b times x squared plus 4. And the x squared plus 4 cancels, so I'm left with cx plus d times x minus 1. I'm once again going to make some good choices and figure out what I can figure out. So let x equal 0, then minus 8 is equal to a times minus 1 times 4 plus 0 plus 0. So negative 8 is equal to minus 4a. A is 2. Let x be equal to 1. Then I have 2 times 1 minus 4 minus 8, 0, 0, b times 1 times 1 plus 4 is 5. 2 minus 4 minus 8 gives me minus 12. Looks like minus 10 equals 5b. So b is equal to minus 2. I'm going to plug in 2 for a and minus 2 for b and do some algebra and meet you back here because you don't need to watch me do algebra. Okay, there's the tedious part of the problem. I went through, I FOILed, I distributed, I FOILed, I combined like terms, and I ended up with 2x squared minus 4x is equal to cx cubed minus c minus dx squared. Oops, I lost my x cubed. That should be an x cubed there. Well, I do have an x squared. 2x cubed. Boop. Over there. And let's see, it was minus over here, so it would be a plus when I pull it over there. Okay, but I end up with c is equal to 2, d is equal to 4. You could also avoid all of that. You could have let x be equal to 0 and x be equal to something else. Somehow you have to figure out what c and d are. And then it becomes easy integration problems. This one's 2 times the natural log of the absolute value of x minus 2 times the natural log of the absolute value of x minus 1. U is equal to x squared plus 4. So du is 2x dx. So this is the natural log of x squared plus 4. Don't even need absolute values because x squared plus 4 is positive, plus 4 over 2 times the inverse tangent of x over 2 plus a constant. So that one was heavy on the algebra, easy on the calc. Okay, we'll do one more and then we'll close out this video and start another one because I don't want them to be too long. This one just has some trig. It has sine squared and cosine to the 5th. I'm going to go ahead and write that as cosine to the 4th times cosine of x. Then this can be my du, so u needs to be sine of x. Let's rewrite cosine to the 4th as a product of stuff with sine. So we have sine of x times 1 minus sine squared of x, whole darn thing squared, cosine x dx. So this is really just u squared. 1 minus u squared would be 1 minus 2u squared plus u to the 4th power times du. Distribute. And because we've done lots and lots of these, I'm going to go ahead and bring sine back. Sine cubed of x over 3 minus 2 sine to the 5th x over 5 plus sine to the 7th of x over 7 plus a constant. We'll make our way down the other column in the next video.